Good evening, students. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
So what were we discussing yesterday? We were doing some problems, right?
Yes, sir.
Yes, sir.
Okay. Now, so I gave you a problem, right? X is equal to a plus bt cube. Did you get the answer using?
Yes, sir.
Okay. Was there a difference in the methods? Did you get the same
Yes, sir.
answer?
There was no, sir. There was a difference, sir.
Yeah. Right. So those who have tried would have understood that. Next is yeah, I hope you're able to see my screen also, right?
Yes.
Yes, sir.
So we will be discussing another concept, that is motion of an object under the influence of gravity. So please write it down. The next heading is motion of an object under the influence of gravity. Okay. Suppose you have a scenario where there is an object at point A on the ground. Okay, if the object is given an initial velocity u in the upward direction, can someone describe its motion? How will the motion of this object be?
It goes up and comes down, sir.
Okay, while it is going up, what will happen to the instant when it reaches a certain height?
It will become 0, sir.
What will become 0?
The velocity.
Velocity.
So the instantaneous velocity of the object at the highest point h is going to be 0. So there are two journeys, right? One is an upward journey and you have a downward journey as well. Right? So if I take during the upward journey, okay, when I take it during the upward journey, if I call this as the maximum height, so there in the process of motion from A to B, what is the acceleration the object is experiencing? The object is moving under the influence of whom? Under the influence of gravity. So we know that there is something called as acceleration due to gravity acting on the particle. So everybody knows what is acceleration due to gravity, right? So acceleration due to gravity always acts in the downward direction. And what is the value of g on the surface of the earth?
9.8
meters per second square, or sometimes it is approximated to 10 meters per second square. That is based on problem, okay? So if nothing is mentioned, sometimes what they will do, they will tell you that you can take the value of g as 10 itself. Then you can take it for the sake of calculation purpose, okay? So during the upward journey, we are going to derive generic equations, guys. We are not going to substitute the value of g. So during the upward journey, when the motion object is moving from A to B, at A, what is the initial velocity of the object?
0.
If it is 0, how will the object go up? If you don't give it a velocity.
Sir, then it can be anything.
I have given, no, I have put it here. Initial velocity is u. Final velocity is only for the upward journey, for the journey
0.
A to B. Here it is 0. Okay. What is the displacement of the object? It is h max. So for the upward journey, the displacement is in upward direction. Velocity is in upward direction. What is the acceleration? it is G. This is in the downward direction. Accepted? I hope there is no doubt for anyone. Is there anything you want me to repeat? Okay. Now I have a question, guys. If you take the upward direction as positive, we can obviously take the downward as the negative values. Right. So if I apply V square minus U square is equal to 2as, then what will be the value of V? 0 minus U square is U square only. 2 into, can I write the acceleration as minus G into the displacement as H max? Okay. So minus and minus will get cancelled. H max will be equal to U square divided by 2G. So the maximum height traveled by the object is going to have the formula as U square divided by 2G.
So why are we putting it as minus G, sir?
Because acceleration due to gravity is in downward direction.
Okay,
so
sir.
Any vector in upward, I'm talking about vector. Since you guys know what is a vector, any vector in the upward direction is positive, any vector in downward direction is negative.
Sir, so for the second half of the journey, till the gravitation will remain negative.
It will be negative. Along with that, other parameters which are in downward direction will also be negative.
So height will be negative.
For example, while you're coming down, the displacement of the object is downward, velocity is downward. All those things will also become negative.
Okay.
Okay. Because when you take a particular scenario, if you fix the directions in the beginning itself, you should be following it till the end of the problem. And secondly, since you asked this question, there is no hard and fast rule that I need to take only upward direction as positive. If I take upward as negative, downward will be positive. If you want, you can do it like that and see, you'll still get the same answer.
Okay.
Can I do and show? I'll do and show. Listen. I'll do it only if you guys will not get confused. Listen to this carefully. If directions are swapped. When I say directions are swapped, upward is taken as negative, downward is taken as positive. Then when I write V square minus U square is equal to 2as. So final velocity in the upward journey is 0 minus initial velocity would have been minus U the whole square. Correct?
Yes, sir.
2 into acceleration due to gravity in this scenario will be
Positive.
G. Positive
G. But displacement would have been
negative.
Okay. So minus and this minus will get cancelled. Minus of U square is equal to 2G into H max. So H max will be U square divided by 2G.
Yes, sir. Okay.
It will be the same answer. Okay. That is the advantage of using vectors. So as I mentioned, there is no hard and fast rule in physics. There is no restriction on it. Only logic is if one direction, you assume it to be positive. The other direction, exactly opposite direction, should be negative. Okay. So keeping the same fact in mind, I'm using the previous notation, guys. This is only for explanation. Okay, this is done. I'm sticking to this notation only. Those who are not back, listen. I'm using the same old notation that anything in upward direction is positive, downward direction is negative. Okay. With that, I'm going to calculate a parameter called as time of ascent. Okay, what is time of ascent? TA. Name itself is suggested. So if I take the upward journey and I give another name called as ascending order, if the downward journey will obviously be descending. So time of ascent is the time taken by the particle to reach from the ground to the topmost point.
Sir, will time of ascent be equal to time of descent?
if air resistance is ignored. Yes.
Okay.
Anyways, we'll see that. Time taken by the particle to reach from ground to maximum height is what is called as time of ascent.
Okay. Sir?
Tell me.
Sir, now you said that if air resistance is ignored, then the time of ascent and descent will be same. But how, sir? The initial velocity is different. Right?
I didn't come to that point. You don't worry about it. Because we are discussing still about the ascending journey. You will get your answer once we discuss about the descending part. Okay. At that time,
Okay,
I'll give you all the logics. So, time of ascent is the time taken by the particle to reach from ground to the maximum height in the ascending order while it is going from down to top. So, I'm using the formula V is equal to U plus KT. Guys, listen to this carefully. I am able to use the equations of motion because the object is moving under what? Under a constant acceleration of how much value?
9.8 meters.
Yes. Or else I couldn't have used this. I definitely need to go for calculus. Okay. So wherever acceleration is not constant, the technique to solve the problem is using calculus, but don't worry. Fortunately, it's not there in CBSE. They'll not ask you. But if at all, if they teach in school, please do let me know. I will bring in some problems. As of now, it is not needed. Okay. Or else we can discuss the same problem that they have taught in your school also. I'll try to give you a different perspective to it. Okay. So time taken by the particle to reach the ground from the maximum height is this thing. The final velocity in the upward journey is 0 is equal to the initial velocity is u plus acceleration is
minus 9.8.
Minus g. I told you will not substitute the value. We'll write it as g only. That value will substitute it when we solve problems.
Okay.
Into t. So, which implies minus u is equal to minus gt, or I can write it as ta. Then ta will be equal to u divided by g. So, this is the formula for the time of ascent. Okay. The time of ascent is u divided by g. I hope I'm clear, right? So there are two things we have found, the maximum height and the time of ascent. Now shall we discuss about the descending journey? During the downward journey, so here the velocity is 0. So can I say during the downward journey, this becomes u and this becomes v. This is A, this is B. And how much is the displacement of the object? It is still h max only. Okay. And let's say the time is t and acceleration due to gravity is still in the downward direction. So what is the sign convention we started with? Upward is positive, downward is negative. Okay. See, some people, what they do is for upward journey, they will have this kind of sign convention. For downward journey, they will change it. But I'm not doing it because it might confuse you. So generally, when I solve a problem, right, this is how I follow. If I take anything to be positive and negative, in the initial stage, I follow the same thing throughout the journey, whether it is upward or downward, I'll not be concerned about it. Okay, but you need to be careful with the sign alone. That is the only requirement. Now tell me, what is going to be the time of descent? So time of descent is written as t with the suffix d. Okay, what is td? Time
Sir,
taken
A upon V?
A upon Vm. Let's see. Time taken by the particle to hit the ground from where? From the maximum height. Correct? Time taken by the particle to hit the ground from the maximum height. I'm going to tell you something important. Listen to this carefully. Okay. So for this, what I'm going to do is I'm going to use S is equal to ut plus half at square. So there are two formulae that involve time in them. One is S is equal to ut plus half at square, or V is equal to u plus at. I'm not using this for one obvious reason. Can someone tell me why am I not using it?
Sir, final velocity is not known.
Final velocity.
Yes, because I don't know what is the final velocity with which it is going to hit the ground, but you will see something interesting. Okay, let's see. So S is equal to ut plus half at square. What is the displacement of the object in the scenario A to B? Okay,
H max.
H max.
No.
Minus H max, sir.
It is minus H max. I told you I'm very particular about sign. Because downward journey, it is minus no. So in the downward journey, the initial velocity is 0 plus half into acceleration is minus g into the time taken by the particle is time of descent square. So minus and minus will get cancelled. But what is the magnitude of H max? It is u square divided by 2g is equal to g by 2 into td square. So 2 and 2 will get cancelled, which implies time of descent will be equal to u square divided by g square and time of descent square. Then the time of descent will be u by g. What is that you guys understood from this?
Time of descent is equal to time of ascent.
Time of ascent is equal to time of descent when air resistance or drag is equal to 0. Drag means the frictional force offered by any gaseous medium.
Can you scroll up?
Sure.
Sir, actually here V is not known, but since U is known, we can solve it using V is equal to U plus AT, right?
U is known, right? V is equal, you will get V is equal to AT. V is equal to G into T. You don't know time also. No? Only now you found no, using this formula.
Yes, sir. Okay.
Now see what is going to happen is note using V is equal to U plus AT in downward journey. What will happen is V is equal to U is 0 plus acceleration is minus G into what is the time of descent, guys? Is it not U divided by G? Time cannot be negative because time is a scalar quantity. So G and G will get cancelled. V is equal to minus U. What is it you're able to understand? Means
Magnitude is equal.
Means with whatever velocity you project the particle in upward direction, the particle will come and hit the ground with the same velocity in the downward direction. Under what scenario? Only if air resistance is 0. Okay. All these things will change if the air resistance is not equal to 0. This is a very, very important fact. So they can ask you one more question. Let's say there is an object which is projected with a speed of 5 meters per second. What is the speed with which it is going to hit the ground? If nothing is mentioned in the problem, no, by default air resistance is ignored. Then you can just write it as 5 meters per second in the downward direction. That's it. Okay, sometimes what we will do, we'll unnecessarily sit and calculate other things. they can give you, there is a building of okay, let's say the object is projected with 5 meters per second and it has reached a maximum height of particular value. Then it is coming down with what velocity it is going to hit. So answer is very simple. If air resistance is ignored, it will hit back with the same velocity. Clear?
Yes.
Okay, this is all
Yes,
about
sir.
this is all about the motion of an object under the influence of gravity. Let's try to solve a problem and see so that we can visualize things better. So there is a ball which is thrown vertically upwards with a velocity of 20 meters per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground. How high will the ball rise is the first question. How long will it take before the ball hits the ground? It's an interesting question. Let's try to draw the scenario for it. Okay. So this will be the height to which the object will rise. And how much is this distance? This is 25 meters, right? Then how much is this height? It
25 plus
is,
H.
no, this distance is h1. From the ground, it is 25 meters.
Yeah.
So the object is given an upward velocity of 20 meters per second. Now they asked, how high will the object rise? Can you guys tell me?
So we
H
can
max.
so 2as is equal to v square minus u square.
Now you have a formula, h max is equal to u square by 2g. Or if you want, you can use v square minus u square is 2as. You will still get the answer. Because this itself is derived using that formula.
20 meters, sir.
So 400 divided by, they told in this problem, g is 20. Sorry, 10. So we'll get it as 20 meters. The height to which the object will get raised is 20 meters. Am I clear with this? Next is, how long will it take before the ball hits the ground? So there is a time taken by the particle to go from A to B, and it takes some time to go from B to C and then to C to D. The reason why I wrote B to C is because if I'm able to calculate the time from A to B, B to C will exactly be the same. Because time of ascent is equal to time of descent. So what is the time taken by the, so total time is equal to time taken from A plus time taken from B, A to B, B to C, and C to D. So what is the time taken from A to B? It is U by G. Plus time taken from B to C is also U by G. Plus the time taken in this case, we need to calculate. I'll come to that. Okay. So for time taken from C to D, using S is equal to UT plus half AT square. Why am I using S is equal to UT plus half AT square? Because displacement is given to us. Okay. Now you tell me the sign convention, which direction you want to take as positive and which side as negative.
Sir, upward positive, downward negative.
So this is positive and this is negative. Okay. So what is the displacement of the object in this case? Minus 25 is equal to one problem I refuse. Okay. Can you guys tell me what would have been the velocity here? Is the velocity?
Sir,
20 meters per second.
It is still
20 meters per second.
It is 20 meters per second because point A and C are at the same level. So when you throw an object with 20 meters per second, to the same level, the object will return with 20 meters per second. So in the journey C to D, U is 20 meters per second. A small correction to be made. What is it?
Minus.
Okay. Into time plus half into
minus 10, sir.
So 5. So everywhere this would minus will get cancelled. You will have 5t square plus 20t plus 25 equal to 0.
Sir?
Tell me.
Sir, this is the journey from
C to D. There is the journey from C to D. Actually, we can make it simple also. So let me solve this first. I just wanted to teach you all the logics. I'll solve it in an easier way also, don't worry. So I hope it is clear till this step, right? 5t square plus 20t minus 25 is equal to 0. So t square plus 4t minus 5 is equal to 0. So t plus 5 into t minus 1 is equal to 0, which implies t is equal to 1 second. Okay. So this will be 1 second. So what is u by g, guys? U is 20.
2,
10.
sir.
20 by 10 plus 1. So 2 plus 2 plus 1. It will take a total time of 5 seconds to hit the ground.
Sir, could you show the diagram once again?
Sure. Done?
Yes, sir.
Okay. I told you I'll teach you in a simpler way, right? So to calculate the time, the alternate method is time taken to go from A to B plus time taken to go from B to D. So what is the time taken to go from A to B? That is 20 by 10 U by G plus what is the time taken from B to D?
Same, sir. 20 by 10.
No, it is not the case. Because in the journey B to D...
Sir, 0 by 10, sir.
No. Then you're trying to say the object is stuck there. In 0 seconds, is it going and
Sir,
hitting
but the
ground?
initial velocity is 0, right?
No, that's not the case, right? That is not how you apply. Time of descent is what? Time taken by the body to go from B to C. It should come back to the same level. And moreover, in time of descent, you will not use this U. You will use the U with which the object is projected from here. Subrajit, are you able to understand?
Yes, sir. Yes, sir.
So this is 20 and this is 25. So it has traveled a distance of 45 meters in the downward direction. Okay. So for time BD, what I will do is I will again apply S is equal to UT plus half AT square. No, but I will not get a quadratic equation. Minus 45 is equal to half into 10 into what is the value of T square? That's what we need to calculate. This will go 5 times. Oh, there is a minus. Minus and minus will get cancelled. This will go 9 times. So T square is equal to 9, which implies T is equal to 3 seconds. Actually, it is plus or minus 3 seconds, but since it is time, I am ignoring the minus sign. Okay. So here it is 2 seconds plus here it is 3 seconds. You are still getting the same 5 seconds. So are you guys able to understand the technique to solve the problem? That is more important for me. Suppose they create a new problem to you guys. Are you able to understand where to apply which formula? Is everyone clear with that thing? Is the alternate method clear or not?
Yes.
Yes, sir.
That's good.
Sir, could you scroll up?
Sure.
Sir, more up, sir.
Done, guys?
Yes, sir.
Okay. Concepts problem. The last concept that is left out in this chapter is the relative velocity. Okay. This relative velocity is something in one dimension. Okay. This relative velocity is what we are going to deal in one-dimensional motion, and it is very, very simple. Okay. So listen to this carefully. Relative in physics means comparison. I think I would have told this already when we saw the concept of relative error, percentage error, relative or fractional error, something like this, right? So relative generally means comparison. And when you talk about comparison, there are two ways in which a comparison can be done, right? So when will you do a comparison? When you know something and when you want to find out about the unknown parameter, right? You will try to do a comparison and say whether this is best or that is best, right? Suppose I give you two TVs and I ask you which brand is going to be better. You would have already had a particular brand at your home. Let's say you have a particular brand at your home. Then based on that, you will be able to judge how the other brand is. Right. Similarly, I give you two pens. You're already using one of the pens. And I ask you to write with the other pen and tell me which one is better. You'll do a comparison, right? So there you're doing a comparative property. In a similar way, if there is an object that is moving, let's say with velocity A, and there is another object moving with velocity B, if you are able to do a comparative study between their velocities, that is what we call it as relative velocity. This is the simplest definition that is possible. Okay. But I just want to give you a perspective to it. Listen. Let's say you're going to an assembly and you'll obviously be made to stand in the order of your height. Right. Let's say there is a person of height HA and there is another person of height HP. If I ask you, what is the height of A with respect to B? What will you say?
Sir, minus of HP minus HA.
Why is minus of HP minus HA? So it is actually like this: height of A minus height of B. To put it in simple terms, I'm trying to find the difference between their heights. That is what I mean by height of a person A with respect to height of a person B, right? So if I get this as a positive value, then what is it I can conclude?
A is taller and B is short.
A is taller and B is shorter. If I get a negative value, obviously it's a vice versa. Like A is shorter than B by a certain value. Right? Are you able to understand? In a similar way, if a car A is moving with respect to car B, if I'm interested to study the velocity of A with respect to velocity of B, then I will write velocity of A B like this. So this velocity of AB is what is read like this. Velocity of A with respect to B is equal to velocity of A minus velocity of B. But I have to do a small correction in my mathematical expression. What is the term I used? I used the word velocity, right? So what is velocity basically? It's a vector quantity. Correct? So only thing I need to do is I need to put an arrow mark on top of it. Whereas when I spoke about height, height is a scalar quantity because it's a distance. The distance between the foot and the head, the top of the head is what is called as height of a person. So velocity of A with respect to B is equal to velocity of A minus velocity of B. Okay. Are you guys able to understand this concept?
Sir?
Tell me.
Sir, then why don't we put the arrow while writing initial and final velocity?
Where? Because I have already put an arrow mark in the diagram. See, whenever you're dealing with vectors, there are two ways of solving problems. If you have already put the arrow mark in the reference diagram, then you can take only the magnitude in the formula. If not, then we need to go with the vector symbols. Okay. Since you asked, I will clear this also. V is equal to U plus AT is there, right? The appropriate way to write it is V vector is equal to U vector plus A vector into T. This is the right way to write. This is the way you need to write actually. But we generally don't follow because textbooks also do the same thing. But if you practice in this way, you can master vectors very well. That is more important. Okay. And secondly, if the diagram already has the sign, then you can write it as V is equal to U plus T. See, for example, in the problem which I solved, I would have clearly mentioned the directions. I will always put arrow marks. Okay. So if you do that, then you need not worry about the vector symbol on top. Okay. So this is C concept, guys. Velocity of A with respect to B is velocity of A vector minus velocity of B vector. There is nothing else outside this. This is what we call it as relative velocity. Generally, this is a formula used for 1 dimension and 2 dimension as well. Only thing is you need to be careful with the sign convention. So this is what I mentioned. So velocity of B with respect to A is velocity of B minus velocity of A. Similarly, velocity of A with respect to B is velocity of A minus velocity of B. Okay. Now, how will you use position time graphs of two objects with equal velocity? Now, observe. So, listen, guys. Position time graph. Okay. If you draw a line in a position time graph, what does the slope of that line represent?
Velocity.
The slope of a line in the displacement time graph is velocity, right? And what do you think will be the relation between the slope of two lines which are parallel to each other?
Sir, they both will be like multiples of each other.
Actually, they will not be multiples. Multiples will happen only in the case of vectors. Whereas with respect to straight line, when I say straight lines, it's a graphical way of writing it. Right? Don't get confused between vectors and this thing. What you told is right only for vectors. That is A vector is equal to K times B vector. Whereas when you talk about a straight line, if the slope of first line is M1 and the slope of second line is M2, then the slope of the parallel lines will be in such a way that M1 is equal to M2. It is very simple. Why? Because if you extrapolate it, that is extended in the backward direction, since they both are parallel lines, this angle and this angle will be the same. Corresponding angles. Hence, their slopes will be the same.
Yes, sir.
That is the reason why their slopes are same. You will learn about this, okay? Don't worry. You will learn about this in your 10th chapter. There is a separate chapter for straight lines itself. There you learn. But here we are taking the application of it. So when you come back to physics, with respect to a position time graph, if they give you two lines, okay, they give you two lines which are parallel to each other, then what can you speak about their velocities?
They will be equal.
They're equal. That is what is meant by position time graphs of two objects with equal velocities. Clear? Second, if you have the position time graph of two particles where they tend to meet, then how is the graph going to be? Okay. Let's say there is an object which started at 0, 40. Okay. And that object started moving so that its displacement constantly increased with respect to time. Hence, the speed, the velocity of this particle is VB. Similarly, there is another particle which didn't start from 0, 40, rather it started at 0, 10. Now, this also started moving, but it started moving with a greater velocity VA. Means I can blindly say that VA is greater than VB. How did I say that, guys?
The slope is
The
greater.
angle is different.
Angle. Very good. You always need to concentrate only on the angle. If you look at this angle theta is more than this angle. So when the angles are greater, tan theta will be greater. Right? That is one way. Mathematically, that is one way to see. The other way is, since the speed of the second particle, the speed of the particle A was more, it was able to meet the particle B at some point. At how much time did it meet? It exactly met at 3 seconds. Then A started overtaking B. You're able to understand, after the point of meeting, the particle A is moving even more faster, right? Obviously. No, it is actually moving with the same speed. But after that point, what is happening? Definitely A is going to win the race compared to B. That is the meaning. Clear, guys? Similarly, if I talk about the position time graph of two objects with velocities in opposite direction and showing the time of meeting. Okay. If I show the time of meeting, then what is going to happen? So there is a particle which started at 0, 40, and there is a particle which started at 0, 10. A started at 0, 10. So B is moving in the direction opposite to that of A. So what will happen, guys? They are again going to meet, but what will happen this time is they will meet even before 3 seconds. Why?
Because one is decelerating, sir.
Say the word decelerate. Okay, you want to use the word decelerating? It is decelerating with respect to another. On its own, see, if I take B alone, B is not decelerating. B is also moving with the speed only. It is also going to have a speed.
But it is because they are moving in opposite direction.
They are moving in opposite direction. That is only reason.
Okay.
It has nothing to do with this. So since they are moving in opposite direction, both are moving in an optimized way so that they are able to meet early. See, it's very simple. It's very simple. Suppose I say there is a ball here, okay, and you are here, and let's say the distance is d. And you started walking. I say, go and take this ball and come. Okay, you started walking. Let's say you're picking this ball at time t1. Okay, that is the first scenario where the ball is still at rest. And the second scenario is there is another person who has come from here. He kicked this ball. Then the time at which the ball is in your hand in the second scenario is t2. Which one will be more?
T1 will be more.
T1 will be more because because you're the only person who's moving. The other object is not cooperating. Whereas if the same object was moving towards you, then what would have happened? You would have got the ball in your hand in a lesser time. That is the same example.
Okay, sir.
I hope you're able to visualize it. Similarly, if the ball was kicked away from you, then what will happen? By the time you catch the ball, it will take more than T1. Because you need to catch up with its velocity and then run faster and go and catch it. Right? It is something like that. Yeah. Okay. Let's see how to solve a problem. Okay. Now, listen. I told you about relative velocity, right? That is relative velocity of one object with respect to other. This velocity VA is written, no? So this VA vector, it can also be written as velocity of A vector with respect to G. This small g represents velocity of A with respect to ground. Okay. So velocity of an object with respect to ground can also be called as absolute velocity. The reason is very simple. If I ask you what is the velocity of A with respect to G, then according to the formula, you should write it as velocity of A minus velocity of G. Though we know the fact that Earth is revolving and all those things, but the speed at which it is revolving is generally considered to be very less. Hence, the value of Vg is taken to be approximately 0, and we will get the value of Vag as VA. So what I'm trying to say is, wherever you're trying to write this value VA, the hidden information inside it is the velocity of that particular object is calculated with respect to the ground, where ground is considered to be at rest. Okay, and we give the name to that velocity as absolute velocity. Am I clear till this point? Am I clear, guys?
Yes, sir.
Yes, sir.
Yes, sir.
There are two parallel rail tracks which run north to south. Okay. So north, south, east, west. Okay. There are two parallel south tracks which run actually not like north to south. They are in the north-south direction. So they are like this. Okay. So train A moves north with a speed of 54 km per hour. Velocity of A is 54 km per hour. 54 km per hour is how many meters per second? Multiply with 5 by 18.
15.
15 meters per second. Everybody knows why it is. Because 1 kilometer is 1000 meters, 1 hour is 3600 seconds. So when you simplify it, the smallest fraction you get is 5 by 18. Similarly, the train B moves in the south direction with a speed of 90 km per hour. So what is the velocity of B now? In terms
25.
of meter per
25.
Yeah, 25 meters per second. Now, what is the velocity of B with respect to A? Tell me. Velocity of B with respect to A is
10 meters.
Sir, velocity of B should be
10
minus
meters.
25. Right?
Yes, it should be minus. That depends on how you take the sign. I'm not forcing you. It is up to you. If you take north as positive, south is negative. If you take south as positive, north is negative. Some people, what they do for the sake of comfort, whichever is having higher value, they will take that direction as positive. It is up to them. But you can ask me, how are we supposed to write the answer? You first do it, I'll tell you how you are supposed to write the answer.
Sir, it can be plus or minus 30 meter per second.
Plus or minus 30.
Depending upon the...
40, sir.
It is 40.
40, sir.
Oh, sorry, 40, sir. Yes, sir.
So,
Sir, depending upon the direction.
So what I do is, I take velocity of B vector as, I will take the downward direction as positive. I will put J cap for instance. Okay. So everybody is comfortable with this, right? Then velocity of A vector will be how much? 15 in the direction of minus J cap. So what is velocity of B with respect to A? It is velocity of B vector minus velocity of A vector. Wait, I'll write it in a fresh page. So this is the direction in which B is moving, which is 25 meter per second. And this is the direction in which A is moving with a speed of 15 meter per second. So velocity of B with respect to A will be velocity of B minus velocity of A. Don't forget the vector symbols. So velocity of B, if I take it as positive 25 minus velocity of A will be how much? It will be minus 15. Okay, means I'm trying to say this direction is positive, this direction is negative. Have this in your mind. So answer is 40 meter per second. Okay, now I'm going to concentrate on the common mistake that happens. So everyone will be happy that they got the answer as 40 meters per second. Someone will come and tell after you come out of exam, they'll say it is minus 40. Okay. But the whole fact is, it is not sufficient if you write the 40 alone. You should write the answer like this. 40 meter per second in the direction of south. This is important. Okay. Suppose somebody has taken the upward direction as positive and downward as negative. Then what they would have got? Did anyone do it?
Minus 40.
So velocity of B with respect to A is minus 25 minus 15. You will get it as minus 40. So here, what does the minus sign indicate? The minus sign indicates that the velocity is still in the south direction, because south is what you took it as negative. Okay. So if you don't mention in the direction of south, your whole answer is wrong. Or if some teachers are kind, they'll cut half mark. That's it. But definitely you lose marks. Keeping the marks aside, in terms of physics, in terms of the grammar of physics, it is wrong. You need to mention. Am I clear with this? So having this clarity in mind, now tell me what is the answer for the next one. Velocity of the ground with respect to B.
So 25 meter per second in the direction of south.
Okay. So velocity of ground with respect to B is velocity of ground minus velocity.
Oh, sorry, sir.
0 minus 25. So it will be minus 25 meter per second. Sorry, not my, yes. So minus 25 meter per second. In the sense, it is having a velocity of 25 meter per second in the direction of north. Okay. Let me give you a vision to this. Okay. I want you to imagine, because I don't have any animation to show you. I want you to visualize it, feel it. Okay. So suppose there is a person sitting in this train. Let's say you are sitting in this train. You know what is the meaning of this 40 meter per second? Actually, the person sitting in the train is moving with the speed of what? What is the absolute velocity with which the person inside the train B is actually moving? He is moving with the speed of 25 meters per second. But since there is a train which is crossing him in the opposite direction with a speed of 15 meters per second, this guy, if he has a velocity sensor in his hand, he will feel as if he is moving with a speed of 40 meters per second. That is why the concept of relativity is coming into picture. Had this train been at rest, let's say this train had been standing in a platform, then what would be the velocity he will be sensing?
25.
B. He'll still feel, actually, he'll feel a little bit slower because the other train is at rest. Have you ever experienced, if something is going in the opposite direction, you will feel that the air is hitting you even more faster?
Yes, sir.
This is what is happening. Okay. Secondly, the meaning of velocity of ground with respect to B means, if there is a person standing on the ground and observing the train which is crossing him in the southward direction with a speed of 25 meters per second, this person who is standing on the ground, because he doesn't have any velocity, the person standing on the ground will feel as if he is moving in the north direction with the speed of the train B. That is 25 meters per second. That is the meaning of it. Okay. So keeping the answer aside, that is the actual meaning of why you're learning this. Okay. Are you able to understand, guys? So to
Yes,
give
sir.
a simple perspective, this is a very, very, very basic thing for something called as theory of relativity. Okay. So there also relativity comes from this. Mechanics is only taken to that consideration. This is what is called as, that is why it is called as relative velocity. Similarly, see, just the topic is relative velocity, but you can talk about relative acceleration, relative displacement. Any term can be given because relative in physics means comparison. That's it. Okay. So this is about the first two options. The third option, we'll solve it tomorrow. About a monkey running and all those things, we'll solve it tomorrow because I have another class. Actually, the concepts in this chapter is over. One part that I need to explain is I'll explain you a few concepts about the graphs. How to draw the graphs under different scenario, these things. Position time graph, velocity time graph, and acceleration time graph. Okay, that I'll teach tomorrow. It's a simple concept. You guys can understand it easily. In the meanwhile, keep practicing. If there is any doubt, reach out. Okay. Any other doubt, guys, from today's class? Clear, right?
Yes, sir.
Yes, sir.
Clear.
Yes, sir.
Good. Good. Okay, we can wind up. Let's see what.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.